Okay, welcome back, and in this fun-filled pre-cal video, one of the things that we're going to look at specifically is reference angles. We're going to look at how you actually find a reference angle, and then we're going to do some examples showing you how it actually works. So first of all, we have to start with definitions of reference angle. So a reference angle is the small angle that occurs between your terminal side and the x-axis. Now obviously we have 4 different quadrants, which means each of these quadrants is going to have its own reference angle and the way of which we calculate them. So to start with, let's look at quadrant 1. So we're going to look at quadrant 1 here. So when we're in quadrant 1, let's say we have this is our angle here. So we would have our angle come up, so this would be your theta. Well, in this case, since your reference angle is the small acute angle that goes from your terminal side down to the x-axis, what we know about quadrant 1 is that your reference angle is the same as the given angle. So in other words, what we like to say is we like to say that in this case, your reference angle equals the theta value. Now, what happens if we are in quadrant 2? So let's look at quadrant 2 here. So quadrant 2 would have an angle that would shoot out, kind of like this. And so this part right here would be your theta angle. What that means is that this part here that goes from your terminal down to your x-axis, this would connote or make your reference. So when we're in quadrant 2, to find this little reference angle says that you have to take 180 degrees minus the angle you were given. Okay, and that's going to give you your reference angle. Now, let's say we are down here in quadrant 3. So quadrant 3, my angle would come down this way. So if I took a look, it would spin around. So this would be my theta value. Well, in that same way, my reference value is going to go from this terminal up to my x-axis. And so this would be that reference angle that we have. So when we're in quadrant 3, the way we calculate it is we would say that we find your reference by doing theta minus 180. And that's going to give us this tiny little chunk that was left over. Now the last one would be what happens if we're over here in quadrant 4. So quadrant 4 would say that we have our angle that comes down. So we start and we spin all the way around here. So this would be your angle. And so when we're looking at your reference, we are looking at this tiny piece right here to be your reference angle. So in this case, because we only want this little piece, we would have to use the entire rotation minus what was given. So here we would use 360 minus the given angle to give you the little piece that was left. Okay? So 4 different quadrants, 4 different ways that we calculate that reference angle. Now when you're doing your work, you need to make sure that you are keeping track of what is the angle in your problem and what is the reference angle that you are using to help solve. So let's look at a couple examples here. So overall, we are trying to find the reference angle and the exact function value if it exists. So first and foremost, I have the secant of negative 225 degrees. I want the reference angle and I want the reference value. So before you even get started, you need to draw yourself your coordinate plane, because we have to figure out where 225 degrees even actually stands. So negative says I'm spinning in the negative direction. So if I remember this is 0 degrees, this is your 360 degrees, going negative 90, negative 180, all the way 3/4 around gives you 270, so I'm somewhere between it. It actually puts your angle to be over here, and it makes this part right here negative 225 degrees. So this was your theta. Now that being said, that means this piece right here down to here is going to be your reference. So we are in the second quadrant. However, we need to keep in mind that this was originally a negative value, so we swung the negative way. Which means to calculate this reference angle, we treat it, so you are going to treat like you're in quadrant 3. What that means is to calculate your reference angle here, we would have to do the 225 minus 180. So we are going to treat this like we were in quadrant 3, and if you remember, the quadrant 3 said your angle minus 180. So this right here is going to give you a reference angle of 45 degrees. Now that being said, we now have to calculate or find its value. Okay, so we've already found its angle. Now we need to find its value. So to do that, we have to look at what we have here in terms of a triangle. So we have this triangle, and so I would draw it kind of off to the side. And what I know about the triangle is that this is the angle I'm looking at, and I just said that it was 45 degrees. Now that makes this a special triangle. What that means is that I know this is 1, and because of being in quadrant 3, that makes this -1, which makes my hypotenuse the square root of 2. Now this just comes from using the ideas of that unit circle. Okay, so your radius here is the 1, but again we're in quadrant 3, which makes it negative. So in order to actually find the value, we have to go back to what were we doing, and in this case we're doing secant. So we are really looking at the secant of your 45 degree reference angle, which is going to give you a value of negative square root of 2. Remember, secant is the opposite of cosine, so you would have, instead of 1 over the square root of 2, you'd have the square root of 2 over 1. So these were the two things that we were looking for. So in this problem, we're looking at the tangent of 675. So what you can see here is that I've already drawn my coordinate plane, and I went ahead and rotated 675 degrees, which is almost all the way to 2 times around. And so we're left with being here in the 4th quadrant. So that means this little spot right here between that terminal side and your x-axis is your reference angle. Now in this case, because we're going almost 2 times around, it means my reference angle has to be subtracted from 720, okay, minus that 675, and that is going to give us that reference angle. Now the reason why we subtract away from 720 instead of like we would have done up here, which is subtract from 360, is because of the fact that we're going to go almost twice around, so we need to use 2 revolutions as our starting point. So in this instance, once we subtract that, we get a reference angle again of 45 degrees. Now just like before, we need to draw the triangle that we have, and so again here would be our triangle. And as you can see, when I draw my triangle, I always kind of try and make them look as if they would look when they were inside the reference angle itself. So this would be your theta value, and we just said that it was going to be 45 degrees, and so we know with the 45 that it's 1 square root of 2. So in this case we have 1, this one is negative, and here we have the square root of 2. Now the last thing we have to do is we have to take a look at what was our trig function. In this case we were looking at the tangent. So this was going to be the tangent of that reference angle, which was 45. And so if you remember, tangent is opposite over adjacent, and so here we get -1. Okay. So there we've calculated the two pieces of information we needed for this problem, which is the reference angle and what the actual value comes out to be. Alright, let's look at another example here. So here we have cosecant of 210. So just like with the others, we need to start by drawing our coordinate plane because we need to figure out where 210 is. So if we remember, we start over here at 0 and it goes 0, 90, 180, 270. So since this down here is 270 and this right here is 180, it means 210 is going to fall somewhere right in here. Once we know where that is, we know this whole angle here is going to be my 210 degrees, which again means that this piece here is going to be your reference angle. Okay. Now from this, again, we're in the third quadrant, and so the third quadrant says that to calculate your reference angle is going to be the angle, so 210 minus 180. So this is going to give me a reference angle here of 30 degrees, which means we have, again, another special triangle. So in this case, here would be my triangle. So again, just like before, I draw it kind of like how mine looks with the reference. And I do that just to keep my bearings. So I know that this is going to be my theta, and I've already said that this was 30 degrees. Because that's 30, that means this is a 30, 60, 90, so that automatically means that down here is the 60 degrees. And the other thing I know about a 30, 60, 90 is I know that across from 30 is going to be 1. In this case it's negative. Adjacent to my 30 is going to be that square root of 3, but again, because of my quadrant, it's negative. And then that means my hypotenuse here is 2. So this again would be that special triangle. Now I want the cosecant. So if we remember, cosecant is 1 over the sine. Sine is opposite over hypotenuse, so reversing that would be hypotenuse over opposite. So in this case we would have the cosecant of my 30 degrees would end up being -2. Okay, let's look at another. Again, we need to start out by putting in your coordinate plane. And then in this case, I have 180 degrees. So what do we know? Well, we know we start on the 0 side, but straight flat is going to be 180. So this means that what I actually have here is my angle lies right here. And so I'm going to start and go over here to 180 degrees. Okay, now since I want negative, reversing it's going to do the same thing. Reversing it says that this would be -180 degrees. Well, we got a little problem here because this does not draw us a triangle. Okay, so what this is actually called is that your reference is actually called a quadrantal. A quadrantal essentially says, so your definition says that your terminal side falls on the axis. And because it does that, we can't draw a triangle. What that also means then is that my reference angle is equal to undefined, which we also can deem as UND if you want to shortcut it. Now, because this is undefined, that also means that if we were to think about the cotangent of that negative 180 degrees, well, this has no value, meaning no reference exact value. Okay? So if you ever come across to where you're lying directly on the axis line, this is what we have. We have a quadrantal, which means that we are undefined. Now, everything that we've done up to this has been done using degrees. Now, what happens if I give you radians? Okay, and again, I ask you to find your angle. Okay, your reference angle and the exact value if the value exists. Well, just like before, we're going to do the same thing. We are going to start by drawing ourselves our coordinate plane, but in this case, instead of using our degrees, we are going to use our radians, meaning we know that this starts with 0, but it ends with, say, 2 pi. We know that this is going to be pi over 2. This is going to be pi. This down here was 3 pi over 2, and so on and so forth. So I have 6 pi over 5, and I need to know where that's going to lie. So one thing that you could do is you could convert it over to a degree if you wanted, or you could take a look at its decimal value, because with each of these, not only do we have the pi, but we also have their decimals. So when we have pi divided by 2, that's the same as the decimal 1.57. Pi would be 3.14. 3 pi divided by 2 is going to be 4.71. And then we have 2 pi, which is going to be 6.28. So one thing we can do is we can figure out what the decimal is. And so here we would have 6 pi over 5 is going to be the same as 3.769. So if you're looking, this is going to fall here in my third quadrant. So we know this decimal is going to come down here somewhere, and that's kind of what we would use to get us started. Now with that, again, we would have the fact that this whole thing right here is going to be 6 pi over 5. This also means that right here is my reference. So notice I can make my triangle. Now with that, I need to be able to calculate, and so the same is going to hold true. This falls in my third quadrant, which says in this case my reference angle is going to be found by taking my theta and subtracting out pi, because that is what my halfway point is. Instead of 180, we'd subtract pi. So with all of these, we can actually convert them over into radian pairs as well. Okay. So in this case, to find it, we would have that my angle is 6 pi over 5. We are going to subtract a pi. Remember, you have to have common denominators in order to subtract fractions. So in this case, you're going to end up with pi over 5. So my reference angle here is going to be pi over 5. Now with that, we have to look very carefully. And so here we know that we have all students take calculus. And so here The ones that are positive are going to be tangent. Well, I want the cosine, and specifically I'm going to do the cosine of my reference angle because that's the same thing we've done before. So in this case, because I'm in the third quadrant, it means my cosine is negative. So in order to find my reference value, I have to look at negative cosine of my reference angle pi over 5. And in order to do this, I'm going to use my calculator. And you're simply going to plug it into your calculator and get a result. So, looking at our calculator here, I want the negative, so I'm going to click negative, and then I want the cosine, so cosine. I'm going to open a second parenthesis. Well, actually I don't need that. This we're just going to do second pi divided by 5 and close it. Then you're going to hit enter, and notice we get this big long decimal here. So you don't have to use the whole thing. However, we did find this value to be negative 0.8091, and maybe I'd round it at 7. 901. Okay, and so this would be the answer that we would be looking for. Now notice this is an estimated answer, so when we're talking about values, my exact value would be the negative cosine of pi over 5. So that's kind of everything that you need to reference in order to get started in calculating and looking at reference angles and how they're related to your trig values. So if you have any questions, please let me know. If you feel like you need additional examples, let me know that too, and I'd be more than happy to work them out. Otherwise, be creative, and I'll see you next time.